Hey, hello. Yeah, hello guys. Welcome back. It was a good session yesterday uh, on the wireframe, and we went when I posted it. Once I posted it, I also informed about it in Discord and the group. They already found a solution for doing the wireframe within iPad. Uh, Hopefully, it comes as a tool in Nomad, and yeah, I'll do if in case it comes as a tool in Nomad. I'll do the video again on that topic, but today's session will be focusing on this design of chessboard which I made on Nomadsculpt, and I'll go through the main features, not as a whole detailed. If in case someone wants a detailed video, I can do as individual sessions, like just focusing on individual parts. But for time being, the main features of these and how I exported it into a bamboo slicer and sliced it for 3D printing. And I'll also show how the vision came through and how the workflow went on, and I'll show you the final product as well, how it looks. Uh, so, so for the chessboard, you can see it just has some handles here for the to be opened. Let me switch on a few settings, gestures. Yeah, the pencil is being currently utilized by my daughter, and I don't have access to it. I need to sculpt or whatever using only my hands. Uh, so for the chessboard, you can see I thought of defining the dimensions first. So my plan is to have a 300 cross 300 wide, 300 mm. I mean 300 mm wide and 300 depth of box, and because that is the best possible size I can print in my bamboo H2C. So I defined the maximum size of the chessboard first, and then the next individual platforms. How do I design it based on that? That's how I ended up choosing these dimensions, and to make sure I'm designing it perfectly within dimension what I desire, I had this. I have shown in one of the videos. I have this scale. Oh, the exposure is too high. I'm gonna reduce the exposure so that I can show it. Yeah, this one was already showcased in one of the videos. It's just a scale to make sure I make the products the desired dimension. So in this case, it is close to 310 mm. I think the Bamboo Studio has 320 or something like that. That is the maximum size we can print up to. So I wanted to make sure the parts I design are under that dimensions. And I thought of assembling each and individual part onto the main frame. So what is the main frame is this is the main frame. So if I go in solo mode, this is how I planned it for phase group and wireframe on. And you can see these are just regular Boolean. I didn't even do quadri measure. Reason why is when you do quadri measure, it automatically changes the number of the tolerance. I can't maintain the tolerance if in case I do the quadri measure. So I wanted to have the perfect tolerance when I design the components in Nomadsculpt, and which is challenging. It is not a CAD tool, which is obviously not a CAD tool. So I had to plan smartly right from the beginning, choosing the right dimensions and right tools how to do in each individual parts. And once designed, I had to make sure it is within the printable limit of my bamboo printer. And so for this case, if you see this box, it is just a box, and all each individual platforms have been booleaned, subtract booleaned, and I just left as it is. I didn't even remesh it, as I mentioned. And if I go out of the solo mode, these are individual platforms. And if I go into solo mode there, yeah, this how they've been designed. So I tried a lot, which works, which doesn't work, and eventually ended up designing. So if you see here, there are two designs here. You can see to the right, it has so thin, flimsy features, which was my initial idea. I wanted to snap this into the mainframe so that it has to have some room to flex. So that is the reason I made this. And when I did a trial print, this just snapped. So what is the dimension of that is, so every one box is 1 mm here. So this is just 2 mm. And so if this is just 2 mm, that means I thought like that should be enough. And if you see that snap, the portion where it snaps, it's close to only 1 mm. So if to be precise, it is 0.5 mm, somewhere around. That's how much I maintain the snapping feature. And if you wonder what is that snapping feature, it is just a torus in a solo mode. It is just a torus from the center, and yeah, you can adjust it. Go back again to that solo. Yeah, so that's there, and I arrayed it all over for the 4 phases, and it is on purpose designed in such a way that I didn't want any support features. So it's a draft, it goes up, it automatically, the slice automatically prints it, and then it goes back again to the top. And when I did this, I did a trial print, it snapped around this, like it cracked, and that's when I had to design it like this, a solid block, just a box, which made it solid. And I tried this, and this worked well. So I'm gonna show you how it looks. So let me move this iPad slightly to the right, and yeah, this is the final product actually. So yeah, this is how it looks. And if you see the feature, it just snaps there, and the dimensions for these blocks somewhere around 30 mm, I think. Yeah, 35. Oh, okay. So I maintained somewhere around 35 squares, and I added some cylinders within the, going back to the iPad. Yeah, here you can see in the middle there is a cylinder. I measured the magnets, and that dimension was maintained for the cylinder with some tolerance on the top and on the bottom. The tolerance is somewhere around 1 mm, 0.1 mm per side. And when I sliced, I made sure it was subtracted from the body. So that's how each and individual block was designed, but I didn't design everything individually. So I just designed one block, and I made sure it worked well. I just spent enough time trialing it out, to and fro trial and errors, And if you wonder what this, like how did I make this within tolerance, I just used uh, it is just a cylinder actually, and with the cylinder in the sense it's just a tube actually. So tube, you can snap the radius, like change the radius at individual parts, and let me show you. That will be quick actually. I'll add a tube, go pull it out of solo mode, go to that tube. Let's say you got a tube here, and I'm gonna change it to 4 divisions. So once it is 4, it's gonna become like this. And in a gizmo mode, in a snap, change it to 45, and you can snap it like this. Now once you got here, you know confidently this is in the origin, because when I added it, I didn't have this gizmo on, so it is in the origin center or origin. So there you can make sure it is there. Let me quickly change it to turntable so that it doesn't turns when I move. This was an issue last day. Okay, and I made sure I snapped it perfectly to whatever dimension I want, because I already zoomed in using my scale tool, so I know how much each and individual block is in dimension, in terms of dimension. So for example, in this case, let's say I'm 10 mm, it goes there, that is 10 mm. So the snaps there, and I'm gonna add a few more radius and sharp. Let's say sharp. Say reduce it, maintain that same radius there. That's it. That is the shape you got. And now if you want more triangles, more polygons on it, you just need to go into linear subdivision, add a few more dimensions, few more features into it, and you can subtract it from any body you want, or leave it as it is. So this is how I designed it. I on purpose didn't use an extra post-processing. Typically I do, so that I can have that blend phases towards the edges, but I didn't do for this design. And you can see that is the reason the print came a bit sharp. But even with it, since you are 3D printing, the slicer already tries to soften the edges. So for me, that was enough. I didn't mind adding a post division after the linear subdivision. So when I delete that, go back to white, go solo mode. Yeah, that's how this block was. One individual block was done. Let me remove the trackball. Now it can move. Okay, so that's how I made sure each and individual box were done, and I made sure they have been properly structured under each folders, so that let's say I want to hide it quickly, that can be hidden, and I want to move it around, I can do it. And these were all just boxes. They might look like, even now I didn't even validate those boxes, so that I can adjust. Let's say I want to add any features there later on. And these are the outer shapes are just blocks constructed around. It is like playing Roblox or Minecraft, just using blocks. Constructed the body and subtracted the main items. So since I was doing it using blocks, I made sure those were placed in the location where I wanted them. So in X-ray mode, hope so it doesn't looks bad. It does looks bad. I'm gonna hide the scale. Okay. X-ray doesn't look good. So that's how the chessboard was designed, and I wanted it to have. Initially, my plan was to have it like a book. I wanted to be closed, and I want to be printed as a single body with hinges. I tried it multiple times with the hinge. I was not comfortable with the hinges the way it came, so I dropped that idea. I thought of going with a single piece long, like large block. And you can see that's the reason I had to go with the lid and box design. So since it is a lid and box design, I uh, made sure, so you can see each and every parts are individual blocks there. Made sure I had enough room for all the coins to be placed in, and once I designed that, then I yeah, then comes the individual coins. So I'm gonna unhide the coins. Yep, is there. So these coins, okay, for the coins, why I thought of designing for myself. I could have downloaded it from Maker's World, right? But the reason why I wanted to design for myself is I wanted the coins to have lights within it. Lights in the sense, whenever I'm playing with it, I want it to have a glow, and once a coin is being captured by the enemy can kill it by turning its neck. That's the basic idea I wanted, but I couldn't find such a design in Maker's World, and I want to have the specific mechanism, like when I turn the neck, it switch off the light. I was trying to find lights around in Amazon, so this was the best option which I could find from Amazon. When you twist it, turn it, it just turns on. So once I found that there is, like, this was the best option I could accommodate within the design which I wanted, like, and it also suits my preference. I thought, okay, I want to buy it and then measure it, and based on that measurement I have to design the coins, because I had to make sure it fits inside, and that is the reason I actually measured it using just vernier caliper. And yeah, I designed it within Nomadsculpt. If you wonder how I did it, it is all the same. A few cylinders, whatever dimension I wanted, measured it and made sure it fits the scale. And once that is finalized, and then I brought that into, so I had it into a separate body so that I can make sure I have a copy of it. So that's when I could bring it into where is it? Yeah, that is there. If we go in solo mode, that is there. And in wireframe X-ray, you can see the bulb, the light is within the coin. So since I want a specific niche idea to be designed, I didn't want to think too much into the design, rather design for this light. That's the main idea, right? So instead of me thinking into each and every feature of it, I thought, okay, I'm going to use AI to give me a coin design, and let's see if I can accommodate within it. Like, I didn't want to do it in Nomadsculpt. Like, I just wanted to create a AI model. I thought of just subtracting it from boolean some cylinders out of it and inserting the bulb. That's what the initial plan was. But eventually I learned, okay, if in case I have this, from AI, how do I separate each and every individual body so that those can be printed as PETG or PLA, the translucent filaments? How can I do that? That is gonna take another time, further time, like it is gonna be a headache. So I thought, okay, this can be used as an inspiration. Just leave it. I'm gonna design it in Nomad from scratch. Why Nomad? I hate the subscription based CAD softwares available in the market, and I just stick with Nomad, and I love it. And so yeah, that's when I started individually building the coin. I know the dimension has been already dimensions of the lights, so I also know the base design idea from AI. I love this the way it came, and I started to build it. So if you go in solo mode, you can see uh, like where is face group and wireframe. These are just boolean, and if you're wondering how I came to this, so I'm gonna hide that. I'm gonna show you the design itself. Solo mode. It's just a tube as usual, and tube is the best tool we could see in Nomad. They have been using it for, and in the upcoming update, they are also trying to introduce tube to tubeless, similar to tube like features for masking, even stroke adjustments. And yeah, in this case, I just adjusted the profile to have those corner chamfers and adjusted individual radius wherever I want. And these 11 is 11 mm in millimeter. So I made sure the bottom is 12 mm radius. What is 12 mm is 24 mm in width. So my plan was to have a coin of 1 inch width in the bottom, width and length and width. So this is like a 1 inch block in the bottom, and I didn't want any coin to go beyond that. So if you see here, it is also 12. I could have gone 12.4, which is to be precise, 12.2 to be precise in mm, but still I just left with 12. And here it is 7, 7, 8, 11, and 10. So this one is there, and I just copied that tube to the bottom to create a base. And this here, what is this ring? If you're wondering what is that, it is just a torus. And as I do before, how does it look like? How does the torus become a square? Just add a torus. Where is torus? Okay, let me take it out so that it doesn't stays inside that folder. And in the torus, I mean, we can solo zoom in, because it's obviously it's gonna, as you add a torus, it's gonna be always small. It adjusts the size. But I'm gonna show how I did it. I can adjust this, and if we go here, I can adjust this. So if you change it to 4, it's already a square. It looks like a square. And if you want it to proper circular, adjust it to 24, might be even 36, as per your requirement of smoothness. And once you've done this, okay, if you can see in the wireframe mode, yeah, add some substitution. Might be linear should work, and then post. Yeah, that's how it became smooth. So that's how I did that, and that is a torus there. This is also a torus. So solo, that is also a torus. I just turned it, and this here is a tube which has been snapped. So you know, with tube we can snap it to vertices. So in this case, I use vertices to snap, and I change the radius everywhere wherever I wanted, and the profile is simply just a square. And that's how this has been designed. And if you look at this part, this is just a cone. Change the number of divisions to 4, and yeah, that's it. That's a cone, and it's upside down, so it looks like that. And this is the bottom itself, and you can see there is a small feature on the top. That is what the speciality of it. So this is where the design, like, I love the design of how the way I made it, because you can adjust this. This is a torus, right? And it need not have any support while you are printing. It automatically smoothly transitions from bottom layer to the top layer and goes back to the top layer. And what I mean by that is, I'm going to show you the actual coin. So the main purpose of this was, when I turn it, okay, this one died because it was on for so long for no reason inside the box. I'm gonna take the black coin. Okay, you can see how the light glows, and in this view, if you see the size, it is a pretty heavy coin with a glowing light. And when I open it, that there, the light is not bright enough, I think. Okay, that there is the feature, and that is this small projection which is made out of a torus. And you see how this goes in, just goes in, and there are 2 pins, one on both the sides, and as the design also shows, there are 2 pins, one on each side, and I need to find a way to turn it. So there is a small groove on the top edge. I'll show what I mean. So top, if you turn it, I'm gonna hide. Okay, this is not the final product. I'll go to the final product so it'll be easier. So yeah, and wireframe mode. You see that small pocket there? That is where this goes, and it gets trapped there, and once it goes there, I turn it, it turns the light. Okay, now the challenge is that the face is going to be flat here, but when I turn it, it shouldn't come out, right? You see there are 2 pockets here. In face group mode, you can see there's 2 pockets. And if you wonder how I made these grooves, I'll also show. Like this portion here was also made out of torus, so it was being booleaned, the same torus which I used in the bottom, same torus in the main. So these bodies, instead of having it like a half one, I made it full and to the center, and I use the same body to subtract and make the top. So but I gave a clearance on all the sides, so when you insert it, it doesn't create friction between the objects. And once I inserted it, I don't want, like, typically you're going to have all these faces flat on all the sides, right? I don't want to like, I wanted to make sure the top doesn't fall off. So that means I made sure I aligned it in such a way that the grooves in such a way that they are not aligned to the actual body. So if you see, where you insert, it goes in a particular angle, and as usual, once you when you flatten the faces, the angle doesn't allows you to the ribs to the slots to come out. There was a design ideology there, and since I made it into using different tool bodies, I was able to make every body with different colors. So why I wanted the color, I made sure I did the rendering in Nomadsculpt using all the features which we have with Nomad. Reason why is, well, I exported it as OBJ file. So OBJ file, as you guys know, it can have all the colors you want. The light is bright. All the colors you want, and while you export in Bamboo Studio, it recognizes all the colors, and you need not paint it in the slicer. The slicer also, if you already load the filaments into the MS system, like whatever desired colors, and you can choose within those color ranges, it automatically turns like changes the body's colors, and based on that, the filaments also be changed. So what I mean by that is, if I go to the secondary screen here, I'll show you the bottom object. This is a white coin bottom, and for the white coin it was what is it? Let's say this is the white coin. The PETG, like, I have used all PETG. I wanted to print it in PETG because I didn't. So reason why I chose PETG is I don't know how much temperature these lights generate. First thing, and also my feature was not to rely on this light at all. I want to redesign these lights in Nomadsculpt and actually print the body of these lights using the PETG or translucent filament, so that the light glows overall the coin. Reason, you can see when this glows only as if like a lighthouse, but it doesn't glows on the top body. So that means because, yeah, obviously the light is focused downwards, and it doesn't go also. And I thought, okay, I had to redesign such a way that the the light gets transferred to all the sections of the coin, and it looks better. Might be even printed in a different filament, which could give a color transitions. So that was the main goal. And to do all these, I don't want to rely on PLA because it also snaps once it's thermally deformed or something like that. So that's why I chose PETG. And printing with PETG, it's a headache, and it takes time. It strings a lot, and that's the reason you can see the surface quality might not be that great as a regular 3D print because it is PETG. The PLA prints would look so good, and PLA and PETG can't be printed together. So I use that as a positive for this case. So I'll show you why what I mean by that. So in this case, it is all PETG filaments, all four PETGs, and the colors here been used. And if we slice, and you can see the section, I also added a few cylinders in a radial symmetry, so that while I insert the light inside, it fits perfectly within it, and it does. But even with that, once I try the top head, it doesn't glow. Like in the first trial, it didn't glow, and that is where I had to introduce something like a regular rubber band to create the friction. So since I didn't have the friction, I I, I asked my daughter if she had some rubber bands in her toy bin. I found these rubber bands, small rubber bands, tied it around the light, and that created the friction. When you turn it, that's when it started to glow. So even with these features, it didn't create the friction. Once I added the rubber band, it just locked between those surfaces and created the friction, and it turns on. You can see those, since I rendered in Nomadsculpt, it automatically shows the path for each filaments based on the color, and that is neat. I didn't want to paint it anywhere. I think this feature has been available for so long. And yeah, that is where the magnet is. You can see I added a pass somewhere around 20 minutes. There will be a pass for this case. Like, this is a single coin, that's the reason it is 20 minutes. So actual plate is at least 1, 2, 3, 4, 6 coins here, and these are all for the pawn. And for the horse, the knight, it was challenging to print the knight actually. I had to add a small where is the knight top, yep. So I had to add a small body, design a small body from Nomadsculpt. This is just few boxes. You see, it's just boxes. There's another box on box, and I chose the same color of the body for this, so didn't have to change any filament. And so let me slice this plate. I'll show you why I did that. It should have been sliced, right? Where am I? Custom mode. Slice all. Slice all. Okay. Hope so it doesn't take much time. So as I said before, I don't know, there is this error which is being visible here. I hope so you guys are able to hear me. But okay, the slice. Oh, since I chose all, it is slicing all the plates, I think. I'm gonna stop this. Okay, this has been sliced already. You see, PETG and PLA are the worst friends. So they don't like it's. You shouldn't print those together, or else the layers are gonna peel off. And I wanted to use that as an opportunity to create smooth top layers, particularly overhanging layers. So you see, in this case, I used PLA. Okay, filament, regroup filament. Here, this was there. I used the PLA on the left, and the right is there. Since I did that, the PLA was used as the support filament, and that's it. But when I did that, what happened was the layers didn't stick, and it kept on failing the knight. That's the reason I added this small box under the knight, and once it got printed, I just sliced it with a snapping tool, and that's how this is. And you can see for the head of the king, the PLA created their individual layers, and you see it also goes into the groove. So this is actually the groove where the bottom half snaps, and this PLA also formed to that, and that is the reason it was a bit challenging while I was trying to remove it. Even though it was a support filament, the print quality was good on the support filament. It was hard to remove. I had to slice it using the tweezers. Yeah, it took a while. I don't know if you guys had a better idea to print it without with something else, or might be some other alignment. Yeah, you guys can suggest, but yeah, this is how I did this. And I have those Bamboo Studio files with me. If someone wants it, yeah, more than welcome to have it. I can also share the Nomadsculpt file. Yeah, you guys can play with it. I also created those supports for. Let me switch to the Nomadsculpt window so that this camera is available. Yeah, this is how I arrange digital coins. Yeah, it sits neatly, and it is actually a heavy board, close to 2 kilogram, I guess, with all the filaments and magnets in it. And I love the way it came. Anything major on this design features was, this was all trial and error. Most of the things, like even the way I introduced the magnets here, even these magnets, and also the handle. So when I designed this handle, yeah, it looked neat in Nomadsculpt. I also thought, okay, I have designed it so perfect for my finger, but it didn't suit my finger, rather it suited my daughter's finger. For yeah, if I redesign it, I would might be remove these grooves. That should already solve this. Other than that, yeah, I had to redesign it multiple times because it was initially planned for a foldable chessboard, but later on I redesigned it as a box. So a lot to consider, consider while I redesigned it. Yeah. Other than that, yeah, I covered most of the things. If someone wants to learn in detail about any feature or any particular thing, like how I did this, yeah, you guys can ask me. These are all major, like most of the items I designed are just tubes, and this is also a tube, right? That's a cylinder. The top of is just a cylinder. That is a sphere. That is a tube, and that was actually a tube before. And these individual parts, I'll show you what that is. That is also, yeah, that is just a tube. Solo view, wireframe, just a tube with a triangular profile. And yeah, that's how this whole design process went on. If someone is more interested in anything specific, how tolerance are being maintained, or let's say if you guys wanted uh, these files available for you, yeah, I can make that. I can put it in my drive and share you guys the link. And also I can even share the what is this, the scale, if you guys want. I did this as a hobby. Once I come back from office and I spend time on the on Nomad, that's how it goes. I would happily share this files, guys. And anything else I wanted to cover today? Yeah, in a way, yeah, I wanted to brag how I designed this. That's it. Other than that, nothing special. Let me know anything you want. Have a good one, guys. I'll come back with something special tomorrow. If someone wants to watch, please consider subscribing. My plan is to do at least under an hour live streams every day from now on. Some topic in Nomadsculpt and whatever tools I used around it, to because Nomadsculpt has its own limitations. I had to rely on certain tools outside it so that I can perform what I intend to do in my daily activity. Thank you. Have a good one, guys. Bye.